Alright, make sure that you have out your z-score chart that looks like this with all these numbers on it. Have this out because we will need it, and don't lose this sheet because you're going to need this for the rest of the year. That's right, I said it. The rest of the whole year. We're almost done. That's so funny. By now everyone should also have this lesson in their hand. Day 8. We learned how to do this yesterday. So I am really hoping that most of you should be able to do this warm-up without me telling you how to do it right now. So I'm not sure if you had a chance to work on it on your own, or if we just started the video right away. But raise your hand if you have finished the warm-up already. Raise your hand if you are all done with the warm-up. Alright, put your hands down. If very few people raise their hand, indicating that very few people are done, then go ahead and pause the video at this point and give the kids, let's say, 5 minutes to try to do the warm-up on their own. Go ahead and pause the video now. Okay, now we've restarted the video. Hopefully everyone has done at least as much as they could possibly do on the warm-up, and I will take it from here. So let's see. On the driving range, Tiger Woods practices his swing with a particular club by hitting many, many balls. When Tiger hits his driver, the distance the ball travels follows a normal distribution with a mean. Time to highlight some stuff. Okay, we have a mean of 304 yards and a standard deviation of 8 yards. Okay, mean of 304, standard deviation of 8. What percentage of Tiger's drives travel at least 290 yards? Okay. I'm assuming let's do z-score for this. So if I made the chart, there's a small chance that 290 might be exactly on one of my standard deviations, but let's just go ahead and go straight to z-score and see what happens. I am going to do a basic sketch. Okay, so let's see, do this with me. So let's go ahead and do a basic sketch first of all. Whoa, that was not straight at all. Okay, here's the basic curve that we're going to be dealing with. Of course, right in the middle, we always put the mean, which in this case is 304. Okay, so there's my 304. Now, what percentage of Tiger's drives travel at least 290 yards? So that 290, I just need to put it on the proper side of this line. So obviously 290 is less than 304. So I'm going to go ahead and put that on the left side of this line. Okay, so 290, let's say it's here. Okay, so that's 290. Now, we want the percentage that are at least, okay, at least 290 yards. Okay, at least 290. Is that 290 and greater, or 290 and less? Okay, I'm hoping that you understand that at least 290 means we are looking for the percentage of values that are greater than or equal to 290. Okay, at least means 290 or greater. So that's what we're looking for. So for that reason, am I going to shade the left or the right? Okay, do not just sit there being silent, guys. Make sure you participate. I'm not there to look you in the eyeballs, but you better participate. Yeah, we're going to shade on the right hand side because that's where the greater than numbers are. So we want the part of the graph that's like this. Okay, the part that's greater than 290. So this is what we're talking about. Okay, that's the part of the graph that we're interested in, the part that's greater than or equal to 290. Now, we want to be able to use the chart to figure out what this percentage is. Now, right now, before I even do another single thing, remember, whenever I use this chart, these are percentages. Are these percentages to the right of the number that we're looking at, to the right of the z-score, or are these percentages the percentages that go to the left of the z-score? To the right or to the left these numbers represent? If you need a hint, look at this picture. Even the little picture in the corner is showing you, look, these percentages are giving you the percentage of the graph that is to the left of the z-score. Okay, so these are left side percentages. So because of that, but look, we want the right hand side. So when we get the percentage off the chart in a little while, how do I convert it from the left side that it will be that we're given to the right side that we want? Yeah, that's when we have to subtract from 1. So anytime we want the right hand side, we're going to have to get the left hand number off the chart and then do 1 minus the left hand number. I'll show you what I mean as we go along. Okay, well, first of all, it's time to change this 290 into a z-score. Okay, so let's draw the line right here. This is where I draw the line. And over here we're going to do z-scores. We're going to come into z-score world. What is the formula for calculating z-score? Okay, your z-score is always going to be the value that you want to convert minus the mean divided by the standard deviation. Okay, so in this case, the z-score for 290 is going to be 290 minus the mean, which was 304, divided by the standard deviation, which was 8. Okay, so just put that in your calculator. 290 minus 304 over 8. Okay, so here's 290 minus 304 over 8. Okay, I get that fraction at first. I toggle it. That's negative 1.75. Please understand this is negative 1.75 standard deviations to the left. Keep that in the back of your mind. Anyway, for right now, negative 1.75. Alright, let's go ahead and draw a new picture. Okay, I'm just drawing a new picture because now I want it in terms of z-score instead of these values. Didn't mean to make that mark. Okay, so in terms of z-score, alright, because z-scores are standard deviations to the left or right of the mean. If the mean is right in the middle, what's always going to be the z-score of the mean? Yeah, the z-score of the mean is always going to be 0. Why? Because these numbers tell me how many standard deviations I am to the left and right of the mean. the mean itself is always going to be 0 standard deviations away from itself. So the z-score of the mean is always 0. Then we've got this 290. Okay, so here's my 290 over here. But I'm not going to call it 290 anymore. I've now converted it to a z-score. So now I'm going to call it negative 1.75 standard deviations to the left. So I am supposed to be finding the percentage of values. Okay, yeah, let me put the shading on this. Okay. So remember, we are looking for the right hand side of this graph, which goes like this. Okay, that's the part that we're looking for. So we want the proportion, the percentage of values of the percentage of z-scores that are greater than or equal to negative 1.75. That's what we're looking for, okay? That's what would be the right hand side. Now, we will go to the chart and look up a z-score of negative 1.75. Understanding that when I find the percentage on the chart, it's going to be giving me the left. The chart always gives me the left. But I will deal with that when it happens. Okay, so let's go ahead and find negative 1.75 on the chart right now. Negative 1.75. Keep that in mind. Okay, because I want negative 1.75, I need to start off with negative 1.7. I'll worry about the 5 later. Alright, because I'm dealing with the 5, wonder can I highlight on this thing? Oh, I kind of can't. When I get to the 5, that's what tells me I'm going to be in this column over here. But for right now, let's do the 1.7, the negative 1.7. Okay, I'm scrolling down. I'm looking for negative 1.7. Okay, and here it is right here. Uh-oh. There we go. Negative 1.7. That's the part that I wanted. Okay, now because it's negative 1.75, then I need to start here, but I need to come over to the 0.05 column. Negative 1.75. It's where they meet up. Okay, so the value that I want is this value right here. Okay, that is where these two meet. The negative 1.75. Okay, so 0.0407. This is the percentage on the left. 0.0401. Okay, so that's what's going on over here. Okay, so on this side I've got 0.0401. That's the left side, but I want the right side. So what am I going to have to do? Okay, well, hopefully you said I need to subtract from 1. So if I want to find the percentage of z values that are greater than negative 1.75, I'm going to have to do 1 minus 0.0401. 0.0401 is the percentage of values that are less than. If you want greater than, you need to do 1 minus the number. Okay, so if I put that in my calculator, 1 minus 0.0401, okay, 1 minus 0.0401, I'm getting 0.9599. Okay, so that tells me that this is 0.9599. I don't think you can see that very well. Let me try again. Let me try a different color. Alright, 0.9599. That's the part that I want. The part to the right. So what would this be as a percentage? That's 95.99%. Okay? So that is the answer to the question. Okay. Alright, let us move on. What percent of Tiger's drives fall between 305 and 325? Well, let's make our graph for that. So, this is what we are dealing with. So here's a normal curve. Here's 304. Okay, 305. Well, that's just a teeny tiny bit to the right, isn't it? Okay, so 305 is just barely like right here. Okay, so there's 305. And then 325 is significantly far to the right from there. Okay, so I'll just put it over here. So here's 325. Okay, so we're supposed to find the percentage that's between those two. So that's going to be the part that's in here. Okay, sorry for my sloppy writing. Sometimes I'm able to do a little bit better than that. So anyway, I want the part that's between 305 and 325. So again, I need to convert both of these numbers to z-scores so I can use the chart. So here I go. Okay, so here come z-scores. Okay, I'll call this first one Z1. So for my first z-score, I'm going to do 305 minus 304. Remember, that's the mean. Okay, over, what was it, 8? Yeah. Okay, let's put that in your calculator and tell me what the z-score is. Okay, so here I have it typed in. I get 1/8. Okay, that's 0.125. Okay, so that's my first z-score is 0.125. Alright, time to get my second z-score. Okay, I'm doing the 325 now. So that's 325 minus 304 again, divided by 8. Okay, put that in your calculator. Okay, so here I've typed in the calculator. So 325 minus 304 divided by 8. 21 over 8, toggle it. 2.625. Remember, this is standard deviations to the right. 2.625. I'm going to need to round this to 2 decimal places. So let's call it 2.63. You know, I should have rounded that one too. So 2.63. Okay, let's go back and round this one. What's this one going to round to? Alright, 0.125. becomes 0.13. Okay, so these are the z-scores that I'm going to use. Okay, so making a new picture so I can keep my mind straight about it is what I'm dealing with now. Alright, so there's my mean. Okay, just for fun, here's 1, 2, 3 standard deviations. Okay, that's just for fun. So the mean is 304. That's like right here. 304. Now, anyway, I've got my my first value is just a little bit to the right of that, correct? It's less than 1 standard deviation, a lot less. So I could put that line right here. You know what, I should zoom in. Okay, so I've got this line right here. You know what, I don't want to put 304 there though, because these are z-scores now. Z-scores, hey. Because they are z-scores, this middle one is now 0. Okay, the middle z-score is always 0. But anyway, so I've got a z-score of 0.13 happening right there. And then I've got a z-score of 2.63. So that's 2 standard deviations and 0.63. So that's more than 2.5 standard deviations. So I'm going to put that like here maybe. Okay, so I just want you to see what I mean by 2.63 z-score. That's 2 standard deviations and change, 63 cents worth of extra. So we're supposed to find the percentage that's between those two values. So we are finding the area in here like this. Okay, that's the space that we're finding. Now, when you want to find the area between two z-scores, we will find the percentages of these two, and then we will subtract the bigger one minus the smaller one. So let's see what's what. Let's go ahead and find these two numbers on the z-score chart. Let's start with 2.63. Okay, 2.63. Going to the chart now. 2.63. Can I undo this? Maybe not. Okay, 2.63. Well, that's going to be on the positive side. Good, so I can get away from those markings. Start with 2.6 and then go over to 3. So here's my 2.6 right here. There's my 2.6. Now this is 0, 1, 2, 3. So this is 2.6, 3. It's where these two meet. Okay? That's why I'm dealing with 0.9957. Okay? So the higher number is 0.9957. Okay? That's the percentage, 99.57%. Now, the lower number, 0.13. Let's find that on the chart. Okay, so 0.1 is right here. 3 is right here. So 0. Whoa, come back to me. Too much. Undo. Okay, so 0.13 is going to be this number right here. So 0.5517. Okay, so 0.5517. Those are the percentages from the chart. If I want to find the part the percentage that's between these two numbers, I just need to subtract. Okay? So if I want to find the percentage of z-scores that are between 0.13, and this is how I do between. I do 0.13 is less than z, which is less than 2.63. Okay? If I want to find the percentage that's between, I need to do, I feel like I should change colors. Getting a little crowded in here. I've got to do 0.9957 minus 0.5517. Okay? So if you want to find the percentage between two z-scores, take the two numbers off the chart and subtract the bigger one minus the smaller one. So let's put that in the calculator. Okay, so I've typed that into the calculator, and I get 0.444. That's 44.4%. Alright, so that's 0.444, or 44.4%. That is the answer, okay? That's the percentage of his drives that are between these numbers. Okay, that's the percentage of drives that are between 305 yards and 325 yards. Okay, so somewhat less than half. Okay, that was the warm-up. Believe it or not, that took kind of a long time. Alright, solving problems involving normal distributions when you know the probability. Look, please understand this is backwards. Now, on the previous problems, we were given numbers. 305 yards, 325 yards, 304 yards. We were given numbers and we were asked to find the probability, the percentages. Okay, now look at this new type of problem that we're going to learn about today. It's backwards. For the problems we're going to be given today, we're going to be given the percent. Okay, the 80th percentile. We are given the percent, and we're supposed to figure out the number. That is backwards. Okay, so the 80th percentile. Let me back up so I can see what I'm looking at. Okay. Now, so just watch out for this. If you're given the percent, understand that we're going to do the whole process backwards. So, what distance would a ball have to travel to be at the 80th percentile? Okay, when you're given the percent like this, okay, 80th percentile, that means we're talking about 80%. What you need to do is go straight to the z-chart. Okay? 80%. What would 80% be as a decimal? Okay? 80% as a decimal is 0.8, or I could even say 0.8000. Okay? So let's find that on the chart. 0.8000. Let's come close to it as we can. Okay, let's see. I'm on the positive side. Looks promising. See some 0.7s, 0.79s. Okay. It's somewhere between these two numbers. Agreed? Whoa, too much. Okay. 0.800 is somewhere between 0.7995 and 0.8023. We need to pick whichever one of these is the closest and work from there. Now some people just automatically go with the one that has the 8 in it. But look at this. Look at these last two digits. This is an extra 0.0023 away. See the 23? Whereas this one, how many of these little numbers would I have to add on to make up to 8? To make it all round up to 8? It's only 5 away. This is 23 away, and this is only 5 away. So the 0.7995 is closer to 0.8. Now, if you can't see that, we could subtract. Okay? Let's do the first one. 0.8023. Let's just go to the calculator. Okay, on the chart we have 0.8023. Now, say if I go minus 0.8, or I could say minus 0.8000. That part doesn't matter. If I subtract, I get this, 0.0023. That's how far apart they were. Now, let's subtract again with the other one. So now if I go, wait, hold on. If I do 0.8000 minus that smaller one, which I think was 0.7995. Let me just double check. 0.7995. If I subtract those two from each other, I get 0.0005. The smaller number here indicates that the 0.7995 is closer. They're closer together. That's why the difference is less. So I said all that to say, let's definitely use the 0.7995. Whoops, I didn't mean to do that. Okay, so let's use a 0.7995. Now let's translate that into a z-score. So looking to the left, I have 0.8. Looking above, I have 0.04. If I put those together, what's my z-score? 0.84. 0.84. Okay, so what I have here is a z-score of 0.84. Okay, that's my z-score. Now, my goal is to work all the way backwards until I find x. Now remember, we have some information that we can still use. We're still understanding that the mean is still 304, and the standard deviation is still 8. So don't forget those numbers. So let's do our z-score calculation, you guys. Remember this formula? That the z-score was going to be the value minus the mean divided by the standard deviation, right? But this time I know the z-score. It's 0.84. Okay? So that's going to give me 0.84 equals. Now this x is what we're trying to find. The x is going to wind up being the distance that the ball would travel. So I'm just going to leave it x for now. Minus the mean. What was the mean? I think it was 304. So x minus 304 over the standard deviation, which I believe was 8. Just take a quick peek, back up. Yeah, standard deviation was 8. Okay, all I really have to do is solve this equation. Do you remember how to solve an equation like this? Okay, yeah, I need to multiply by the denominator. That's the key. Alright, so if I take this and I multiply both sides by 8. So I'm going to multiply by 8 on both sides, right, Maddie? So these 8s are going to cancel each other out. Okay, so that's going to get, you know what, I don't really know exactly what I'm supposed to do in all these boxes. I'm going to be honest with you. use the table. And you know, I'm not really just following these steps. I'm just doing what comes naturally. So I hope you'll let me slide for my lack of perfect organization. But if I do this, 8 times 0.84. Okay, that's 6.72. Okay, so now I've got 6.72 equals x minus 304. What am I going to do now, man? Add 304 to both sides. You got it. Okay, so that gives me x equals, let's see, plus 304. So I can just, straight from here, I can just go plus 304. That's giving me 310.72. Okay, this is the value that we were supposed to find. So what distance would the ball have to travel to be at the 80th percentile? Alright, and I know this is the space where we're supposed to have a summary statement. So the ball would have to travel 310.72 yards to be at the 80th percentile. Okay, I'm going to pause for 10 seconds in case you're writing any of this down. Alright, I'm moving on. Now, one of your classes is going to be cut short, but one of your classes is full length. So if you have the short class, you may already be out of time. So that may be the lesson for you. And we don't have homework in this class, as you know. So if you don't get to the second paper that I left with the sub, that's okay. The sub can just hang on to that second paper since they don't actually have homework. But if you have a full class, then you probably still have some more time left, maybe. So let's keep going and see what happens. Let's go ahead and do problem number 1. The level of cholesterol in the blood is important because high cholesterol levels may increase the risk of heart disease. Does this sound familiar? Weren't we working on a problem like this yesterday? But remember, the reason why this one's going to be different is because instead of asking you for a percent, this time I'm giving you the percent, the highest 8%. And I want you to find the value that would trigger that percentage. So this is one of those working backwards problems. One more time, if you're given the percent, that's when you have to start with the chart and work backwards to the x value. Okay, so that's what we have to do. So let's see, critical information. The level of cholesterol is important, blah blah blah. Da, 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 da. The mean is 170. The standard deviation is 30. Okay, and we're shooting for a target of 8%. So 8%. Let's start with that. Let's convert that and find it on the chart. So 8% equals, what would this be as a decimal? I have to move the decimal point 2 times. So that's 0.08. If I wanted to look at it as 4 decimals, I could say 0.0800, like this. This is the number I have to find on the chart. Okay, let me put a little note to myself. Find this on chart. Okay, that's what we're going to do first. So let's find this on the chart. Okay, 0.0800. I got 0.5. These numbers are all bigger than that, so I must need the negatives. Okay, so here these numbers are pretty close. Right here I've got 0.0808. That's 8 away. Okay, let's see. Is there anything closer than that? 0.0793. Huh. How many away do you think that is? I think this one is 7 away. And this is 8 away. So this one I think is actually going to be closer. Okay, one more time. Let's subtract and find out. Okay, let's start with this one. 0.0808. Okay, that's 8 away. Now let's subtract the other one. 0.0800 minus, now what was it? 0.0793. 0.0793. Okay, so that second one is only 7 away. The first one is 8 away. So the 0.0793 is a tiny bit closer. So that's the one I'm going to use, guys. 0.0793. So focusing on that number, the 0.0793, I need to translate that into a z-score. Look left, look up. Looking to the left, I've got negative 1.4. Looking up, I've got 0.01. Huh. Put those together, what do I get? Negative 1.4, 1. Negative 1.41. That's going to be my z-score. Negative 1.41. Okay, so z-score is negative 1.41. Now it's time to do my calculations and turn this back into an x value. So I'm going to use the formula. Z is going to equal my value minus the mean divided by the standard deviation. So that means negative 1.41 is going to equal my value minus 170 over 30. That's what I need to solve out. Okay, Kelsey, how am I going to solve this equation? Maddie, what do you think? Let's see, I need to change colors. Yeah, I need to multiply by the denominator. So I'm going to wind up multiplying both of these sides by 30. So multiply by 30, multiply by 30. Okay, so these are going to cancel out. So that's going to give me, I got to do 30 times negative 1.41. Times negative 1.41. That gives me negative 42.3. Okay, so I've got negative 42.3 equals x minus 170. What do I do now, man? Add 170 to both sides. Okay, so plus 170. So yeah, I can just do plus 170 right now. 127.7. Okay, this is the value I was looking for. I wanted to know what cholesterol level is the highest 8%. Okay, the top 8%. So here's where I can write my summary statement. Alright, a cholesterol level of 127.7 is at the highest 8%. Instead of saying of, I'll feel more comfortable if we say above. A cholesterol level above 127.7. Okay, because thinking in terms of a normal curve, the 127.7 is like this number right here, but that highest 8% is the part that's to the right of that. That's the highest 8. So saying above, that's more appropriate. Okay? Now, if you're still around, your class is probably almost over. So you probably don't have time to do number 2. But just in case, I'm going to start working on number 2. You know how we do. Don't pack up until it's time. Don't pack up early. So I'm going to go ahead and start number 2, and let's just see how far through it we can get. Is this a problem that I'm going to have to work backwards, starting with the chart? Let's see. I know I have to work backwards anytime I'm starting with the percent. So this says the lowest 15%. As soon as I see them given the percent and I'm being asked what level, I know I have to work backwards, starting with the chart. So 15%. Okay, 15%. What is that as a decimal? Move the decimal point twice. That is 0.15, right? That's 15%. Just to make it match the chart better, I like to make it 4 wide. So 0.1500. I just added on those extra zeros. Okay, just making a note to myself. Let's find this on the chart. Okay, find this on chart. Okay, let's go to the chart. 0.1500. Okay, 0.1500. I feel like I'm in the right area. Okay, because there's my 0.1492, that's pretty close, and then 0.1515. It's somewhere between these two. Which one is closer? Okay, well, this is 15 away, but this one is only 8 away, if you can see that. So this is the one that I want, 0.1492. Okay. Okay, so on the chart, this turns out to be 0.1492. Okay, so what's the z-score for that? Okay. So the z-score, well, let's look back. 0.1492. To the left, I've got negative 1.0. above I have 0.04. Put them together. Negative 1.04. Negative 1.04. That's the z-score. Okay? Negative 1.04 is my z-score. So remembering that the z-score is always the value minus the mean divided by the standard deviation. This equation becomes negative 1.04 equals the value that we're looking for minus the mean, which is 170, divided by the standard deviation, which is 30. How do I solve this equation, guys? One more time. I need to multiply both sides by 30. Multiply by 30, multiply by 30. Okay, so I need 30 times negative 1.04. That's negative 31.2. So negative 31.2, those are going to cancel out, so that equals x minus 170. Add that 170 to both sides. Okay, so come back over here, just do plus 170. 138.8. So that's 138.8. Alright, that is the value that I was looking for, 138.8. So the lowest 15% will be below 138.8. So that's going to be our summary statement. Let's go ahead and get that down. I should use a different color. Okay, so the lowest 15% will have a cholesterol level below 138.8. Okay? That is how you solve these problems. You should be able to do number 3 on your own. Alright, I am going to post this on... Actually, on second thought, number 3 is pretty tricky. So, pay careful attention. You're probably going to need some help on this. We're supposed to find between what cholesterol levels do the middle 75% fall. Alright, to help me visualize this, I've drawn myself a little picture. Let's say this is a middle 75%. I'm trying to find, the values. And I'm starting with z-scores and working my way backwards. Anytime I'm starting with a percent, I'm going to start with the chart, turn that into z-scores, and then turn those back into actual cholesterol levels. Okay, now if this area in here is the middle 75%, okay, and maybe I could shade that in or something. So this is the middle 75% is like this area right here. Okay. What percentage does that leave for the outer portions? What's left for the outer part? Do you see that if this is 75%, that leaves 25% total for the rest? But this should be evenly divided. So if I've got a total of 25% left, okay, I've got 25% left to be shared here and here. Exactly how much will that be on the left side and the right side? Well, what's half of 25? Alright, I'm pretty sure that is 12.5% over here and 12.5% over here. Okay, we're going to need those numbers, so it was important that we did that. Now, if I want to translate and find z-scores, I need to take these percentages in this chart somehow and find numbers off of my z-score table. Now, I ask you again, these numbers on the table, are these values percentages to the left of numbers, or are they values to the right of numbers? These percentages are all percentages to the left. So, looking back at this picture, I need to look, these are the two values I'm trying to figure out, okay? I'm trying to figure out this spot and this spot. But these numbers are not the numbers I need. Well, one of them is, but I need the numbers to the left of each of these arrows. Now let's start with this one. This one is the easiest. What is the percent of the picture to the left? Now I always need the left because that's what's on my chart. When I get to these numbers, these are always numbers to the left. So I need to start off with percentages to the left. So what percent is to the left of this arrow? Well, to the left is 12.5%. Okay, so for this arrow, I'm going to talk about, for this side of my boundary, I'm going to talk about 12.5%, which turned into a number that I might find on my Z chart. I need a decimal, so that would be 0.125. So that's going to be my left number on the chart. Okay, maybe even put a 0 on here. So 0.1250. Okay, I'm going to be looking for that on the chart in a minute. Now, looking at this next boundary over here, I'm not going to just use the 75. I need the percentage of this picture that is everything to the left of this boundary. Okay, because that's what those numbers on the table are. They're numbers all the way to the left. So I'm going to have to add what two numbers to find the percentage to the left of this arrow. Yeah, I'm going to have to add the 75%, which gets me to here, plus the 12.5%. That's going to give me the whole distance. So what's 75 plus 12.5? Just in case you couldn't do it in your head, that's going to be 87.5. Okay, so remember, this is giving me the value all the way to the left, so this arrow is at the 87.5% mark. Okay, 87.5%. Now, translating that back into a decimal, moving it twice, that's going to be 0.875, and why not just throw a 0 on there so it matches. Okay, these are the values that I'm going to look for on the chart. Chart. Okay, those are the values I'm going to look for on the chart. So, once I find them on the chart, then I will have my z-scores. So here we go. Z-scores. Alright. Okay, so let's get the z-score from the 0.1250. Okay, so let's see, there's 0.1230, here's 0.1251. Okay, I don't think we're going to get any closer than that. So here we go. 0.1251. That's as close as we can get to 0.1250. It's one away. So let's translate that into the z-score. To the left, I've got negative 1.1. Above, I've got 0.05. Put them together. Negative 1.15. So negative 1.15. Okay, so as a z-score, I'm talking about z equals negative 1.15. Okay, now let's do the other z-score. 0.8750. Okay, we are looking for 0.8750. These numbers seem too small. 0.4. Okay, this starts off at 0.5. Okay, I see some 0.8s down here. I'm looking for 0.8750. 0.872, 0.8749. That is pretty darn close. One away. We're not going to be able to get closer than that. 0.8749. We were shooting for 0.8750. Let's translate this guy into a z-score. So looking to the left, I've got 1.1. Looking above, I've got 0.05. Putting it together, 1.15. Okay, now looking back, is that really a mystery? Let's see, 1.15. We knew we were looking for the middle 75%. So that mean of 0 should be right in the middle. So if the left value was negative 1.15, the right value should be positive 1.15. So we probably could have done a shortcut right then. Anyway, these are the two z-scores. Now it's time to turn them both back into regular values by using our formula. Z-scores will always equal regular values minus the mean divided by standard deviation. So hopefully we'll have enough space for this. Okay, so let's do our calculations. I might have to zoom in. Okay, so we'll do one conversion with the first z-score of negative 1.15, and then we'll do it separately for the second value of positive 1.15. Let's start with this one. Remember, the z-score, negative 1.15, should always equal the normal value minus the mean, which in this case was, what is it, 170? Yeah, so 170 divided by the standard deviation, which was 30. So I just need to solve this, and that'll be my first value. So of course I am going to multiply both sides by 30. Always multiplying by the denominator. Okay, that way those are going to cancel each other out. 30 times negative 1.15. That's negative 34.5. Let's add 170 both sides. So I can just do plus 170. 135.5. Okay, that's one of the values on the boundary. That's the lower boundary in cholesterol. Now let's do the same thing with the higher z-score. So 1.15, the z-score, will always equal the regular value minus the mean divided by the standard deviation. Once again, I need to multiply both sides by 30. That way these are going to cancel out. 30 times 1.15, well, when we did negative 1.15, we got negative 34.5. So this time it should be positive 34.5. So 34.5 is equal to x minus 170. Let us add 170 to both sides. So 34.5 plus 170. Okay, so that's 204.5. Okay, so that's the other boundary in cholesterol. Okay, so it's time for our summary statement. The middle 75% have cholesterol levels between 135.5 and 204.5. Okay, that was pretty tricky, but that is how you do that. Whoops. Just back up so you can see the big picture. Okay, so just to review, that problem is pretty tricky. We were given a middle 75%. As soon as we see that we're given a percent and we're being asked for cholesterol levels, we know that this is one of those problems we have to work backwards, somehow starting from the chart and working back to the values. This one was tougher because they gave us just the middle values. So we decided if the middle was 75%, that left 25% to be shared equally on the ends, 12.5 and 12.5. The numbers on the chart are always to the left, so that meant the lower boundary is the boundary to the left is 12.5%, but the upper boundary, which we changed into a decimal of 0.1250, the upper boundary was more complicated since it reflects the boundary where all the way to the left is a total of 75% plus 12.5. This is the 87.5% line because it goes all the way to the left. We translated that into this decimal. We looked for both of these on the chart and we found them, and they corresponded to z-scores of negative 1.15 and positive 1.15. We worked the formulas backwards using each of those z-scores to find the two cholesterol levels that would surround the middle 75%. Kind of a tough problem. Alright, that's all she wrote.